Okay, now we're going to do lesson 9.3 where we mix the stoichiometry problems. That is, we're going to have mixed inputs and outputs. Okay, so you're going to be given something, but like in the first group of problems, we always gave you the mass. Now you could get the mass, you could get the STP volume of the gas, or you could get the number of particles or moles of one of the reaction components. And then you can be asked to give your output to calculate the quantity of something else as a mass, a volume, or number of particles or number of moles. So basically starting anywhere on the left side of the mole map, figure out how to get to anywhere on the right side of the mole map. So let's get started with this. So as with all stoichiometry problems in chemistry, the beginning is a balanced chemical equation, and then you're going to have a strategy. You're going to look at the given, what are you giving as your starting value, and you're going to figure out how to use your dimensional analysis, your fence post method, to move from the given to the desired ending quantity. And it always involves applying a series of conversion factors, multiplying by a series of fractions equal to 1. So to do this, to pull off these problems, you're definitely going to need a periodic table. You are probably going to want that mole map diagram like I have shown here, which is inside of the front cover of your packet, and you're absolutely going to need a calculator to work them out when you're done. So get those things together and let's work out some example problems. Okay, so here's an example problem. We have calcium carbonate reacting with hydrochloric acid to give us carbon dioxide, water, and calcium chloride. And now here's the question we're posed. If 12.3 grams of calcium carbonate is completely reacted, how many liters of carbon dioxide gas are produced at STP? So I've taken the time to write out the chemical equation already in the space below, but it's not balanced. So copy it down, see if you can balance it. You can pause it if you want to, and then I'll show you the correct balance. Okay, so if you've taken the time to balance it, you should see that you need to add a coefficient of 2 in front of the hydrochloric acid. All the rest of the coefficients are 1. Okay, so what I generally like to do is just write down kind of what I know to start with. And I know that I have 12.3 grams of calcium carbonate. So I'm going to write that down here. And I'm supposed to find the volume of the carbon dioxide in liters. So it's time to break out the mole map, and let's see where we're at. So we are starting from grams, that's mass of substance A, okay, and so our output is going to be in volume. So we can see we need to go from mass of calcium carbonate to moles of calcium carbonate. Then we're going to use the mole ratio to go from moles of calcium carbonate over to moles of carbon dioxide. And then we're going to use the 22.4 liters in a mole to take us to the volume of carbon dioxide. So let me clear this out of the way, and we will set this up. All right, so again, start by what you're looking for. We want our output to be liters of CO2. Write down the given value or the starting amount, 12.3 grams of CaCO3. Okay, first conversion factor is going to have the molar mass of calcium carbonate on the bottom, which is 100.09 grams of calcium carbonate is 1 mole of calcium carbonate. All right, that takes us to moles of calcium carbonate. Now we need to figure out how many moles of calcium carbonate corresponds to moles of carbon dioxide. In other words, for every 1 mole of calcium carbonate, how many moles of carbon dioxide? And since neither one has a coefficient, we know they're both 1, so it's 1 for 1. So 1 mole calcium carbonate is 1 mole of CO2. And now we have it in moles of CO2. We don't really need to worry about the molar mass of carbon dioxide because they didn't ask us to say how many grams. We're supposed to give the output in liters of CO2. So we know that a mole of any gas, CO2 is a gas, at standard temperature pressure is going to be 22.4 liters of that gas. Okay, let's check our units. So we ended with liters of CO2. That doesn't cancel out with anything, but we just canceled moles of carbon dioxide here with moles of CO2 here. We cancel our moles of calcium carbonate there and there. Then we have grams of calcium carbonate there and there. So again, the only unit left is the one that we want to end up with. So we can be pretty certain we have it set up correctly. And now we pick up the calculator and go to work. So I just stopped the video and worked out the answer, and I got 2.75 liters of CO2. I rounded it to 3 digits because the original measurement had 3 significant digits in it. So that would be the liters of carbon dioxide we could expect if that much calcium carbonate reacted. On to another example. Alright, here's a second example where there isn't any mass involved at all. So this question's asking us, based on this equation, how many moles of barium chloride, that's this reactant, were consumed, so how many moles were used up, if the reaction produces this many formula units of precipitate. So first of all, we have to identify the precipitate. So we're going to look over here at the reaction products. This is a double replacement reaction where the two reactants are aqueous solutions, but one of the products right here is a solid. That's going to be our precipitate. That's going to form and settle out. So we have this many formula units, and we said formula units, not molecules, because this is ionic. So this many formula units would have to come from how many moles of this. So I find it very helpful to write down kind of what I know and what I'm trying to find out. So I'm going to put down how many moles there, and I'm going to write down 7.34 times 10 to the 24th formula units. Okay, so that's my starting point, the formula units of the barium phosphate precipitate, and I'm trying to find moles of barium chloride. So let's set this up. Okay, so let's start with what we're looking for. How many moles of barium chloride? And then we're going to put our given value, 7.34 times 10 to the 24th formula units of Ba3 PO4 2. Okay, so what I'm going to do is continue this myself. If you want to pause it and see if you can work it out the rest of the way on your own, I will tell you you're going to need 2 more conversion factors. So if you want to pause it right now and try to see if you can fill it in, meanwhile I'll fill it in and keep going. So the first thing we need to do is move from formula units of barium phosphate into moles. So we know that, and we want the unit of formula units to be down here and moles to be up here, so that we can divide out the formula unit of barium phosphate here. So I know that a mole of anything is Avogadro's number of particles. That's formula units of Ba3PO4 2. So there, our unit divided out, and that would be equal to a mole of Ba3PO4 PO4 2. And I know it gets a little tedious to write these down, but it's important to keep straight which substance we're dealing with. Okay, so since my output is asked for in moles of barium chloride, what I now need to do is relate moles of this substance in the reaction to moles of barium chloride. And I can see that there's no coefficient here, so that's a 1. So in other words, for every 1 mole of this I get, I had to use up 3 moles of that. So it's a 1 to 3 or 3 to 1 ratio. And since barium phosphate is going to go on the bottom, I'm going to put 1 mole of Ba3 PO4 2 on the bottom, and I'm going to put 3 moles of BaCl2 on the top. And I don't know about you, but I'm really glad I don't have to write barium phosphate anymore, because I just canceled the unit out there. Moles, barium phosphate canceled out. So again, I'm down to the unit of moles of barium chloride. That's what I was looking for. There aren't any other uncanceled units. So now it's time to pick up the calculator and go to work. And I've already worked this out. If you want to pause me and work it out for yourself, go for it. But I got the answer of 36.6 when I rounded it to the correct number of digits, and that would be moles of barium chloride. There you have it. Mixed stoichiometry problem. All right, ladies and gentlemen, so we're going to give you the post-video question for the lesson. So here's an unbalanced chemical equation. So first you're going to have to copy this down and balance it. And then what we're starting with is 15.5 liters of hydrogen gas placed in a balloon. And it's combusted in the air. So there's going to be a big explosion. And the product of that explosion is going to be water. So the question is, how many grams, that's what we want to know, how many grams of water is formed in the reaction? So again, use your mole map and your calculator and your periodic table and work this one out and be ready to discuss it when we meet again. Good luck.